Okay, just fixed my air compressor, and all I did, I proved I'm really a dumbass, which I already knew about that on electrical. So I spent a week dealing with stuff, ordering parts, and there was nothing wrong with it. So all I know is that little air compressor sucks. But what I did was, it worked in the morning, I went to did some blast, and it wouldn't work again. And I've been tracing it ever since. So I took the panel pack in here. I looked for anything that smokes or stinks or has any issues. This was way back here where I could barely see it, so I moved it further out so I can get to it. And these capacitors in here are all wired up correctly this time. When I took everything apart, I didn't label everything correctly, and I got one wire reversed. So I had to figure out how these capacitors are wired. And these are wired in parallel to each other, not in series and not common. I had both leads on one terminal here, which is not correct. So, but there's nothing wrong with these capacitors. They're just fine. The wiring was fine once I put it back correctly. It works fine. Now, I'm no genius when it comes to alternating current because I'm a DC guy. I'm really good with plus and negative, but when you start talking about commons and grounds and color codes and stuff like that, all I know is that in there all looks the same to me. The one I know for sure is green is a ground, negative is a positive, and positive is a negative when it comes to alternating current. So black is hot and white is ground. But they don't call it that, they call it common and something else. And I don't know. So basically your white ground is a working ground and your green ground is a safety ground. And even that varies between different people's how they wire stuff. So I don't know. So anyway, this thing was triggering on. When I flipped the switch on, this would trigger in, but the starter would not work. The motor would not work, nothing worked. So I'll leave that off so you can see it. So when you look at triggers right now, see? It's got a switch and comes on like that. I was doing that before, but the motor wasn't coming on. So anyway, so I went and bought these new capacitors here, which are, I spent a day or so studying what to get, and then I spent 70 bucks getting them. These are all USA made capacitors. I don't want to buy cheap crap. These are the same, these are slightly bigger rating. So what I found out was you can be a little bit bigger in size, but not way bigger. And the voltage can go up one size, not hurting, so you can go from 250 up to 350 and it doesn't hurt anything. But you don't want to be less than what these numbers are. If you're on the low side of your resistance on your capacitor, then it could be bad also. So these here, this is the same thing I had, except it's a higher voltage. Mine was a 65-370, and then this one here was the same 250 voltage here, but it also is 220, so it could be low or high. And mine is instead of 378, it was 350 something I think, and 430 instead of 455. Pretty much the same thing, but the big difference is the size. That's why I didn't put it in. This is a lot smaller than that black one right there. See, a lot smaller. Plus this one has a resistor in there, which I have no idea what it does. This one does not. So there's two things I didn't like about it. So I figured I'd try it again and start playing with it. Now there's a pressure switch in here that basically turns on the mag switch, that turns on the electric motor, and then there's a rotary switch in here which is a governor that shuts it off so it doesn't keep cranking on the thing and burn everything up. So this pressure switch could be bad, causing other issues. My friend's shop, he said he had a switch that went bad and it put the motor into a stall condition. So I'm thinking that his pressure switch turned on his mag switch, but it only had enough power to get one leg to work. Because down here, these legs become hot when the switch engages. These two hot legs here. To get 220, you get two 120 leads or 110 leads, whatever you want to call it. And we got 220, 230, 240 volts, it varies. So anyway, basically you got two hot leads is a 220 volt system, single phase. And then my milling machine's a three-phase system, so it has three hot legs, and there's no grounds, it's just three hots. And that's why you have to have my phase converter back there, because that converts you into a, it has two legs going in, and it comes out with three legs hot. And it's all done with a bunch of these capacitors, there's a little stack them in there, that's how it does it. But it takes the rotary phase of the motor, and it gives you full power. If you just have capacitors only, you don't get full power to your motor here. Because three phase, you can flip it on and off. you have instant refer. You have to let it coast down. You flip the switch the other way, it instantly turns the other direction. So you got 100% torque in the opposite direction as soon as you flip the switch. If you just have capacitors, you don't get that unless you got modern computer controlled ones, and I think they can do it again. But the old rotary system works good. I like mechanical stuff. It rarely fails. So anyway, all this stuff I had to relearn how all this stuff works because I'm not an AC guy. All these wires are yellow in here, which is great for checking stuff. I spent 2 hours online trying to find information. I can't find squat on dual systems. It's all 110 based stuff. So you just basically use common sense. I talked to a couple of my friends that are electricians, but they wire stuff. They don't fix motors. And I just kind of bounce things off the head. But anyway, these are the compressors that are in there. These are the ones that I bought. So this is 65 microfarad. That's a microfarad symbol there. And this one's a 440 volt. The one that's in it was a 370. This one's the same size, the same look as the one that's in there. See, it's that silver one right in the middle. Same thing. So this one I'm comfortable on changing, but this is the run capacitor. So the starting capacitor, basically, just think of these like little batteries. They basically jump the voltage up to put more power through the motor to start it, and then once it starts, you shut it off. Same thing happens on your car electric starter motor. You get a full 12 volts to it, and then when you have your ignitions, you run on lower voltage, and they cut it back a little bit. Except that's not on the starter mode, that's on the ignition side of it, but different, but same type thing, I guess. But anyway, this is basically it bumps the voltage up and it lets it start the motor under load, because this is a heavy loaded motor because it's got an air compressor, so you're fighting a full head pressure when this thing starts. So it has to have a heavy duty electric motor. This is a 750 or 7.5 horsepower single phase 220 motor. Farm use, extreme heavy duty farm use, so it's a $2,200 motor right now in 2023. So I didn't want to replace it. So, but anyway, I got that all fixed there. So I didn't put any of these in there because I don't like them. I don't think they're exactly right, unless I had to change them. So the direction I was going was there's a governor inside here. You got to take the whole motor apart to get to it on this side of the motor. And it's basically a rotary switch that expands out. It's got weights on it, so it opens and closes. So when I flipped the switch on here, the mag switch was energizing, but nothing was going through the system. It wasn't putting any power to your motor. So the only thing I think of is the mag switch was saying, or not mag switch, the rotary switch was saying to be disconnected, because you have points in there. It could either be fried or it could be open. If it was fried, that would be connected all the time and burn the motor up. If it was not connecting, you wouldn't get any starting action. The starting capacitor would never work because you didn't have power to it. But if it wasn't working, it would at least try to start it with just a regular power, and you would have a hum or buzz or something. But so that didn't seem like that was the problem. But that's the only thing that was left. I was going to take this apart, just put a jumper straight across and eliminate it. And that was one test, but I wasn't going to do that till the end. I was going to go into this next if this didn't work. But what I found was that I'm a dumbass, and that right there is a rubber button. Because I was up here working here, getting all the wiring figured out. And I also cleaned the wiring mess that was in here. It's not all a big rat nest like it was. These were all interwrapped together. Now there's separate legs that are separate now. You can pull them out individually. And it's not a big rat nest. You can identify what things are now. And I said, what's this thing up here for? And I'm feeling back here. What the hell? Some kind of a switch? What is this damn thing? And I put my thumb over here and I pushed it and click. And so what happened was, this is a circuit breaker and it was popped. So for a week I've been there because a circuit breaker was popped and I didn't even know there was a circuit breaker here. So what a dumbass. So now when you turn this thing on, all your guts fall out too. So anyway, so there you go. 100% dumbass. Yeah, that's me. So there you go. So next time your air compressor fails, go look for a circuit breaker someplace, see if it's got one. Because I know the power going to the wall is on because my phase converter over there runs out these two hot leads right here. So I know it has power to it. But anyway, it was just a circuit breaker, and the circuit breaker eliminated all this stuff, kind of like this was doing, but differently. So that's why I had nothing, because it completely shut the power off when that breaker was flopped. So there you go. Live and learn. Now you can go get some work done.